So in this video, I'm going to give a very quick approach towards the result of Gaussian integral. The very quick term, I mean very quick. It's like I can solve the Gaussian integral within like 10 seconds. So in order to do that, we need a very important tool from the Eulerian function, gamma x. And gamma x is defined two ways. One way is the integration form. It is equal to from 0 to infinity e to the negative t times t to the x minus 1 dt. And this is one way to define our gamma x. The another way is gamma x equals limit. Limit n approaches infinity, and n minus 1 factorial times n to the x over x sub n, where this symbol is called the Porch-Hammer symbol. Porch-Hammer symbol. And it is defined as x times x plus 1 all the way to x plus n minus 1. So it's like a ascending factorial of x until the total number of multipliers equals n. So how do we use the gamma function to solve Gaussian integral within 10 seconds? So next thing we will do is that we need another proposition from gamma function. So proposition is that gamma x times gamma 1 minus x equals pi over sine pi x. So the first thing we will do is to prove this identity, and then I will give the quick method of solving this solving Gaussian integral, which is Gaussian integral is just equal to integration from 0 to infinity e to the negative x squared dx. So this is the Gaussian integral. So how do we prove our reflection rule? This is called the reflection rule of gamma function. Reflection rule. So the first thing we need to do is to firstly weigh our left hand side is equal to gamma x times gamma 1 minus x, which equals limit n towards infinity times, so for the gamma n term, so for this term we have n minus 1 factorial n times n to the x over, so we'll just write the Porch-Hammer symbol explicitly, x times x plus 1 all the way to x plus n minus 1. So this is our first term, and our next term is equal to so this term. So okay, I'm sorry, I should write this as x instead of n. So So the next term is just equal to n minus 1 factorial times n to the 1 minus x over 1 minus x times 2 minus x times all the way to n minus x. Simple, it's just a simple substitution of Prochamer symbol, and we replace all the x by 1 minus x term. So, nextly, we merge those two things, and we will have limit from n to n towards infinity, n minus 1 factorial squared times n over, and we now merge every term by using the difference of square formula. So this will equal to x times 1 squared minus x squared all the way to m minus 1 squared minus x squared times m minus 1. Oh, m minus x, I'm sorry. Okay, so now by noticing that this term is just equal to 1 squared times 2 squares times 3 squared all the way to n minus 1 squared. So now we divide all of those terms by both denominator and numerator. We will have limits and approaches infinity. So x times 1 minus x squared over 1 squared. So I assume you see the reason why we do that. This times 2, sorry, it's not 2, it's still 1. 1 minus x squared over 2 squared, all the way to 1 minus x squared over n minus 1 squared. And for the last term, we divide n by n minus x. We will have 1 minus x over n. And we close the bracket and write to the negative 1. So, and now I'm going to rewrite this expression by using a different notation. And this will be equal to, sorry, this will be equal to x times this term. So this notation stands for the multiplication from n to 1 to infinity times 1 minus x squared over n squared. And I assume you see the reason for this. If you approach n to infinity, so this term will just equal to this, and the last term, I assume that the last term is ignored for its value is very approximately equal to 1. So what should we do next? The next thing we need to do is to use the Weierstrass decomposition of sine x. So the Weierstrass said that sine x is equal to x times n equals 1 to infinity 1 minus pi squared, pi times n squared divided by x squared. And we'll have, so from this we'll have sine pi x is equal to pi x times n minus n equals 1 to infinity 1 minus x squared over n squared. So from this we will have our this term equals, so let me just rewrite this. So this is actually equal to pi over sine pi x, which is equal to our right hand side. And that's the end of proof of this proposition, which gives us the reflection rule. So after having our reflection rule, why we can use that to solve our Gaussian integral within 10 seconds. Now let me show you the reason and the secret and the magic behind this amazing method. So firstly, we need to rewrite our gamma x. So we need to give another definition of gamma x. So gamma x, as we know, is equal to this integral time, sorry, it's not, let me see, e to the negative t, so e to the negative t times t to the x minus 1 dt. So now we send all our t to x squared, we send all our t to z squared. So dt by dz is actually equal to 2z. So now we have gamma x is equal to integration from 0 to infinity e to the negative is z squared times t to the it's not t, times z to the 2x minus 2 times 2z dz. So we'll have this equal to integration from 0 to infinity e to the negative z squared times z to the 2x minus 1 dz. So now we can just observe that gamma 1 over 2 is equal to 2 times integration from 0 to infinity e to the negative z squared dz, which gives us gamma 1 over 2 is just equal to 2 times our Gaussian integral, which is amazing. So now we'll just set our x equals 1 over 2 in our reflection rule, and let's see what will happen. So gamma 1 over 2, if we set x equals 1 over 2, we'll have gamma 1 over 2 squared equals pi over sine pi over 2, which is equal to 1, so this equals pi, which gives us that our gamma 1 over 2 is equal to the square root of pi, which gives us our Gaussian integral is equal to, which is from 0 to infinity, e to the negative z squared dz is actually equal to the square root of pi divided by 2. And this is our final result. And this is the end of video, and I hope you find this helpful, and I will make those integration technique videos in the future, and I hope you can stick to my channel if you like.